Our next lesson in slope will be with parallel and perpendicular lines. Now, you should have a good sense or understanding of parallel and perpendicular lines from your experience in geometry. From an algebra standpoint, what we need to realize is how the slopes values relate to each other. And so we have this nice little summary here in the box, and we can see that parallel lines, their slopes values equal, and you can see what that would look like visually, how they would run side by side and never intersect based off of your geometry definition. So from an algebra definition, we know that the slopes are equal to each other. Now, for perpendicular lines, the slopes are going to form 90-degree angles, and the easiest way to see that mathematically is through the slopes being opposite reciprocals, or sometimes students like to call them negative reciprocals. So if we take the original sloping line and we take the opposite value and we make a reciprocal, then that will be the slope of the perpendicular line. And so we'll have some problems asking you whether different lines are parallel, perpendicular, or neither, and you can see in example 3, this is a perfect example of it. We give you two lines passing through a couple points for each line. So your first task is to find the slope of each line and then make a comparison of those slopes. And so we can see that the slope of the first line is -2/3. The slope of the second line is 3/2. And if we make a comparison of these, they are actually negative reciprocals of each other. And then, of course, another test that we can also use if we look up in our previous summary is that the slope of the two lines should equal to -1. And so that is another way that we can tell if the slopes are perpendicular. And so if we take -2/3 and multiply them times 3/2, we get a -1 value. So there's a couple different ways for us to make that determination. So then we could say that these two lines are perpendicular. So what we want you to do is to get some experience doing that. So for sample problem number 3, you're going to basically work a similar problem using the example as a guide. So go ahead and pause the video and work on that now. So our first task here is to get the slope of the first line, and we'll use a little 1 after our slope to just signify that that's the slope of the first line, or line 1. And so we have a slope of 1/2. Our second slope is going to give us 4/8, which is also going to equal to 1/2. And so we can see that here we have two slopes that are equal to each other. So if M1 equals to M2, we now know that those are parallel lines. And of course, if we wanted to, we could plot the 2 points and then draw a line through them, and we could visually see whether they were parallel or not. Now, on this final little table, one of the things that we need to be able to do is to quickly be able to determine what the slope is, if it's parallel or perpendicular, without actually having to solve anything. So if we're given an equation of a line and we recognize the slope, we can quickly determine the slope for parallel and perpendicular lines as well. And so what we'll do is we'll quickly fill this table out. So for the first column, we're given the slope of the original line. And so what this table is saying is, in the second column, if we're given a parallel slope, we want you to figure out what the slope is of a parallel line to the original slope. So go ahead and fill out the middle column. And so what I'm going to do here is, if the slope of the first line is 1, then my parallel slope should also be 1. And so if it's -3, the parallel slope is -3. And if we can just continue down, we see that the parallel slopes are all the same for the original slope. Now, if we're looking for the slope of a perpendicular line, we want to do the third column. So we need to compare the first slope, and we need to take the negative reciprocal, or sometimes called the opposite reciprocal. So go ahead and try to fill out the third column now. Okay, and so for the first slope, the reciprocal of 1 is obviously 1, but we have to take the negative value of that. For -3, the opposite of -3 is just a positive, and then the reciprocal is 1/3. For 4, we're going to have -1/4. For 5, the reciprocal is 5/2, and of course we have to take the negative. For negative 1/3, that's going to give us a positive 3 over 1. And then, of course, that is simply just 3. And then last one is 0. Now, this is the tricky one, because the reciprocal of 0 is not 0 over 1. If we recall, if it's a slope of 0, we're dealing with a horizontal line. So now, if we're taking the perpendicular to a horizontal line, we're dealing with a vertical line, and we know that the slope of a vertical line is undefined. And so it's a tricky little one, and it's a very important one for you to know. Our final video on slope will now deal with an application problem, so we can see how this working with slope will come into a word problem, and you could see it in that form as well. So in this example number 4, we basically have a home repair manual giving us an idea of how far up a ladder should go up a wall. And the wall is at least 1/4 of the height where the top of the ladder hits the wall. So a ladder hits the wall at a height of 12 feet and should have a base 3 feet from the wall. So it says find the recommended slope. And so if we look at our solution for part A, we're going to use just a quick visual, if you will, where we can actually get an idea of what this looks like. And so if we have a wall, and then we have the ground, and then we know that we basically have a ladder here that has a rise of 12 feet up the wall, and that the ladder should be 3 feet from the base. And so of course this would be our rise, and this would be our run based off the given information. And so if we wanted to find the maximum recommended slope, we would do rise over run, which would be 12 over 3 equaling to 4. So that's just a visual idea of what slope looks like. Now it says find the minimum distance a ladder's base should be from the wall if you need the ladder to reach a height of 20 feet. And so now if we're going to go up the wall a little bit higher, that means we need to come out away from the wall a certain amount as well to keep that 12:3 ratio, if you will. And instead of really using 12:3, what we can do is we can use 4 over 1. And so then we can come up with a proportion. So some of y'all may remember proportions from Algebra 1. You can see in Part B solution we set up a proportion of 20 over x, and x is representing the distance from the wall, equals 4 over 1, and then we're going to use cross products, or what you may know as cross multiplication, thus giving us a value of 5. And so we should really be 5 feet away from a wall to safely be 20 feet up the height of the wall. And so that's a good basic application problem. So let's take a look for one for yourself. So sample problem 4, why don't you go ahead and pause the video and take a little time to work this problem and see if you can figure it out. Okay, so coming back here to sample problem number 4, we can see that the roof rises 5 feet, and so we see the word rises, and that's pretty clear. And this says over a horizontal distance of 15 feet. Now this is a little less clear, and so what we're dealing with here is a horizontal distance. What that's really referring to is the run. Remember, run is the horizontal back and forth, and the rise is the vertical. And so it says find the slope of a roof. And so our slope is just going to be, if you remember, rise over run. So that makes this very simple. We have a rise of 5 feet over a run of 15 feet. Now we should always get in the habit of reducing our improper fractions, and so we can see we have a slope of 1/3. Now, say we're in the construction business and we need to rebuild this roof with a slope of 2/5. But it's still going to have a horizontal distance of 15 feet. Again, remember, that's representing our run. We want to know what the rise of the roof will be. So what we're really concerned about is we have a run of 15 feet, but we don't know what the rise will be. And we need to make this equal to our new slope. And so we set up a proportion here. And then now we just need to use cross products or cross multiplication to figure out the value for x. So we're going to say 5 times x is going to equal 2 times 15, which is 30. And x is going to equal to 6. And so if we look at what we were trying to figure out, that was the rise of the new roof. Okay, and that's just a simple word problem using slope.